to our webcast. My name is Linda Dabbs, and I support the ICT programs and your presenters. May I have your attention? I'd like to go over some important housekeeping before we get started. As a reminder, this webcast is being recorded. By participating in this call, you can sense that your name, your voice, and your contribution will be included in our recorded materials. Please mute your phones and your computers. We can't stress enough how important this is to do. And please do not put your phone on hold if your company plays music. It does come through the line and into the recording. If background noise from any line becomes an issue, I will mute the line, but it doesn't mean we don't want you to speak up. You do have the ability to unmute yourself. We know you have many choices for your time, and we want you to have an enjoyable experience, and I'm here to assist in any way. So at any time, for any reason during the webcast, I can be reached through the chat feature. And now, I'd like to turn it over to your presenter, Randy Rhodes.
Good morning, everyone. I'm Randy Rhodes. I work at EPRI, and particularly I'm involved with a new project set called Geospatial Informatics. I've also been participating over the last few weeks with the weekly call that is conducted by Tom Moran. Tom is speaking this morning. He is the Executive Director of the All Hazards Consortium. And after he finishes presenting some background on the sensitive information sharing environment, Carrie Hicks will be speaking. Carrie is a Senior Junior GIS Specialist at Duke, and also acts as the chair of the GIS Committee with this sensitive information sharing environment initiative. I thought this would be a perfect venue for Tom and Carrie to talk about their work, particularly in light of some of the past calls that we've had as a GIS interest group, and in light of the directions that we're taking over the next couple of years here at EPRI. I'll have a few minutes at the end of the call to talk about upcoming events, so stay tuned for that. We will take Q&A after Carrie has finished, but during this time, feel free to message through the chat window with Linda or myself. I'd be happy to take your questions and bring those into Q&A at the end. With that, I'll turn it over to Tom. It's all yours.
Thank you. Thank you, Randy. Can you hear me okay?
Sounds good.
Okay, very good. Good morning, everyone. My name is Tom Moran. I serve as the Executive Director for the All Hazards Consortium. My background is in the private sector. I came out of the telecom space, retired in 2003. I worked with a number of states as part of my role as a liaison at the executive level between state officials and our private sector leadership within a number of different companies that through acquisition, was probably 5 or 6. Retired from Verizon, ultimately worked with GTE, became Verizon, and then retired in 2003 and started helping the states work together with the private sector. And over the years, this organization, the All Hazards, let's go to the next slide. The All Hazards Consortium had expanded. It's a state-sanctioned 501c3. It was started by D.C., Maryland, Virginia. Formed in 2005. Has since expanded to about 15,000 stakeholders. Mostly private sector now across the United States and Canada. Sectors include electric, fuel, comms, transportation, health, finance, logistics, supply chains, retail. We focus on a number of issues and problem solving that require states and government to coordinate with private sector. The private sector doesn't need help many times. They just need government to kind of move things out of the way so they can get on with their business. But there are many things that prevent that. And that's kind of our swim lane, is that cross-sector or sector to government. So we've been at this a long time, and we pick these complex problems, form committees, work the issues with states and federal government. And the whole goal is to help get business back to business faster. This helps business, it helps states, it helps everyone. So, and as we conduct our Blue Sky Day efforts, our whole focus is problem solving. So we focus on the people, what the problem is, the impacts. Then we use and turn to our technology partners or folks that actually do the heavy lift, do the work, provide the solutions. We partner with those folks so we can stay focused on our mission, which is really building trusted networks of people around specific problems. Let's go to the next slide. So today I'm happy to talk to you about the SISE, this sensitive information sharing environment. So what created it? Well, a number of things, but private sector requires, during a disaster, very fast information flow. And today there's more information coming at private sector and states, quite frankly, than they can possibly deal with. We've learned very quickly what information is reliable. What information is a prank? During Sandy, we saw information that there were sharks in the Toms River, which ended up being a prank. But had we not had somebody watching that knew how to discern that social media post back then, which was just a prank or fake news, whatever you want to call it, could have been very disruptive. We also had another situation where a gentleman was drowning in his truck and he was using Twitter to send out SOS. Well, they determined that was real. They pulled him out of the truck. And that got us into this whole, how do we judge good information from bad information? How do we find okay information and make it better? So the SISE was created around this as a way to share sensitive information with government to government or government to business or both. Next up, it was created, number one, to build communities, to build trust. It starts with trust. So you have a variety of different government-funded portals. The private sector doesn't use those, so they wanted their own. So they developed the SISE, which is modeled after the defense industrial base models and really seems to answer the mail. Let's go to the next slide. So today, the SISE is a framework that combines people, process, and technology, along with identity, vetting, and validation, so that it is able to protect information. So if you, the data provider, want to know and make sure who's looking at your data, for what purpose, and for how long, the SISE will handle that. It removes liability. It leverages federal investment. It's a really unique, one-of-a-kind animal. Let's go to the next slide. And what makes it unique is that the vetted people come together within the trust framework, no media, no regulators. It's all operators within states or sectors, private sector, and they develop use cases, which are just problem-solving frameworks. And each problem is divided down into a problem, which gives birth to other problems. And out of that, these groups create solutions. Those solutions are many. They could be a playbook. They could be an app. They could be process. They could be dashboards someone already has, but no one knows about. They could be third-party solutions. They could be partnerships. It could be applied research. There's many different solutions to a single use case. So we're working about 50 use cases now across a number of different sectors, multi-sector issues and topics. And the SISE provides that framework. It's not a system. It's a place where people can come together to develop trust and solve problems. Let's go to the next slide. So we use this use case-based approach to divide people and information into pockets, right? So we organize work groups. We have a template we've created with 6 steps. Those solutions create and are placed in the SISE. We repeat the process. We build an ongoing library of solutions that we use for our partners and members. And then we sustain beyond elections. One of the things the SISE does is survive turnover at the state and local level, which is a crazy problem for the private sector. I get to know Randy in the state. We build trust. There's an election. Randy's gone. And I got to start all over again if I'm the private sector. Well, the SISE and the consortium bridge that gap and provide continuity of those relationships going forward. Next slide. So some of the current apps, we have a number of them, probably over 80, but we try to divide these apps for a specific problem. Every app, every data set, every dashboard was built from scratch to solve a specific issue. So we have these organized. This is a sample of some of the products that have been developed. When the SISE develop it, it has to be unique. It has to be simple. It has to require quick production of results, right? And it can't be available anywhere else. The SISE doesn't want to compete with other people. So when it creates a solution, it does the search. Many times we use other people's solutions. It doesn't really matter. The idea is to make it a place that all the information is vetted, the people are vetted, it's tried and true, it's operationally focused, and these things work very quickly. So they're not be-all, catch-all solutions, but it's kind of like Fandango, right? You want to go to a movie, there's a Fandango app, you use it in 30 seconds, you got your movie, you got your tickets, it mashes up together 6, 7 data streams, some public, some private, some financial, and boom, you got your solution. And that's where the private sector wants to go. So the SISE is really looking at these data and vetting data, okay, and organizing it better for decision-making support. Next slide. So what we came across was through a partnership, and Carrie Hicks is going to get into this deeply, we came across this concept called an operational readiness level concept. This allowed us to organize data and realize, okay, now that we have a way to vet the data, now how do we build decision tools or dashboards that use ORL 1? The ORL ranking is 1 to 4. ORL 1 is the most reliable, vetted, and so forth. And so we create these tools that allow our members to know when you come to one of these ORL dashboards that all the data has been vetted, it's validated, it's the most reliable, and you don't have to waste any time validating the data. We put a lot of energy. These are checked. This is done by right now 11 utilities, Verizon, some food, transportation sector in 6 states. So we have this committee, and we're still building this process on vetting. But the whole idea is to create tools that provide 30-second decisions. You know, training, you come to it, you know exactly why you're there, and boom, you've got the information you need. And we can develop these going forward very quickly now now that we have a standard for data scoring. Next slide. So as I mentioned, we have these dashboards that combine information. Here's an interesting one that is all of the state 511 sites all into one single dashboard. Well, for people that do GIS, this is no big deal. But 90% of the market doesn't even know this is possible. And the trick is marketing and outreach many times. Not the technology, it's the people. It's the education of it. It's the aligning their needs with a tool. And like I say, we see this all the time where the GIS, it's no big deal. It's a service. These guys provide it. Yeah, but who knows about it? That's where we come in because not many people know about it or are trained in how to use it. So that's what some of the SISE tools do. Next slide. This is a product originally developed by NASA through a $5 million small business agreement with Storm Center Communications. We use this dashboard to merge public, private, and sensitive data into one common operating picture. It's the only one in the nation like it. We use it for power restoration. So we coordinate 30, 40 states with 100 companies, many utilities, providers, contractors into one place. And this provides us fleet movement, declarations, waivers, state information, private information, all on one dashboard. And it was built to provide mutual assistance support in the electric sector, but now it's being used by communications and comms and fuel and a number of other ones. So again, it was built to solve a specific problem, but over the years it has evolved. Next slide. Another example is a single place that houses all of the validated government declarations and waivers and guidance. We work with our state private sector committee. They populate this. We've used this in every storm since fall of 2016. And it gives the private sector one place to go to download vetted, validated documents. Great service, very simple, but extremely effective. Next slide. Another example of Harvey, Irma, Maria. We use this dashboard to coordinate pretty much every state in the nation with the largest mutual assistance movement of utilities in history, basically, according to Edison Electric Institute. But it gave us the ability to coordinate government and industry. Right there is our swim lane. And we had that movement without a hitch. It expedited power restorations in Puerto Rico, but also in Harvey and Irma, it moved resources around the country with the states watching and being able to assist with police escorts, closing way stations, and a number of other benefits for that. Next one. Some of the other examples was housing. We work with one of the data providers as a housing unit. We found hundreds of thousands of open condos, rental apartments during Sandy. We use those same contacts during Harvey. We're able to provide FEMA that data within an hour of them requesting that. So because we build these trusted relationships, we know the data providers. We're able to get them quickly into the mix. Whether we're solving a lodging issue or fleet movement, it doesn't really matter. But this is a housing example of some of the data partners we have. Next. The supply chain, we're working on a big one right now through data that's not available on the market. This is a group that manages the movement of commercial vehicles. And you can see the before slide, lower right corner, that's trucks moving through Houston. And then after is what happened to that truck movement after landfall. So we're working on a trust arrangement using the SISE to protect their data. This will give us live information on road road closure, because if there's red traffic moving on it, that means the road is open for commercial traffic. Really a big game changer for commercial vehicle movement. First electric, then fuel comms and so forth. So this is how the SISE can protect the data without just giving it to government, and now it's open, and now it has, it violates agreements and privacy and so forth. The SISE protects that. Next. We have several committees under the SISE. Carrie is on with us from our GIS ORL committee, but we have a number of other committees working problems in these specific areas and developing solutions, many of them GIS based, because GIS is just a quick way for decision makers to know what's going on. And so we're really glad we have Duke Energy and a number of other utilities on this along with states. So next slide. And I think that brings me up to 2 more slides, and then I'll introduce Carrie. We have a methodology here on how we produce solutions, starting at the bottom. We have data sets. We run those through the operational readiness level, and then those feed into our use cases. As you move to the top, that's where we come out with dashboards and tools and apps. So we start at the top and work down. So we find what's the problem, what sectors, who are the people that need to be involved, what's the data needed for a solution, and what's the security level of that data. Then we drop down into our use cases, we write it up, we've got it documented, then we look to see what data we need, we vet it through the ORLs, and boom, we've got a solution. And you see the data analytics is where they want to go. They want to start analyzing data so this can be more predictive in nature. Hey, we've seen this before. Here's what could happen. DHS has partnered with us. We're partnering with some of the federal labs to leverage some of their analytic capability. But overall, we're looking to use this ORL concept as a way to help federal, state, and local all get a standard they can use to vet GIS data and improve the data as well as the standard over time. Next slide. So if you want to learn more about the SISE, you can go to siseusa.org, and there's a mind map. There's a mind map there that you can get information on that as well. Let's go to our next slide now. I can introduce Carrie, and Carrie Hicks runs our GIS ORL committee, and Carrie's been working on this initiative for a little over a year and a half. And so, Carrie, we're glad to have you brief the folks up on it, and I think you'll all see this standard is really can be a game changer for both operational decision makers as well as GIS professionals. So, Carrie, why don't you take it from here?
Great. Thank you, Tom. Good morning, everyone. Tom mentioned my name is Carrie Hicks. I am a GIS analyst at Duke Energy. I've worked at Duke for a little over 5 years. I got involved in the All Hazards Consortium a couple years ago, and at the time there was this concept floating around called the operational readiness levels. And for me, it was very resonant because the role that GIS plays at Duke Energy is very much interfacing with operations, and oftentimes, we come from different worlds between operations and GIS, and that provides some unique challenges. And when a major disruptive event occurs, oftentimes these two worlds collide, and operational professionals come to GIS with various needs and requests, and GIS is eager to oblige, but usually under intense time constraints. And the decision makers are often not familiar with the technical particulars involved when working with GIS data. They just know that they need to accomplish a highly important task and that they require good information. So that's where the operational readiness levels come in. So I'm going to present my screen. And I have a story map that I'm going to go through. So what this story map is going to provide is a background, and then I'm going to dive into some of the particulars of the model itself. Let's imagine that you're a GIS analyst who is working to support hurricane response for your company. You help support a web mapping application that provides situational awareness for higher-up decision makers within your company. You've gotten a request to find live data on gas availability at gas stations and to add it to your web map. Our crews are getting bottlenecked by evacuating citizens, and gas stations are beginning to run out of gas. So you know you have to provide this data fast. So you do some research, and within a few minutes, you come across an ArcGIS rep service that displays gas buddy data. So you grab that rep endpoint and you add it to your application. The decision makers then take that data and use it to inform routing decisions as they bring in crews from surrounding regions. Now imagine that you are a decision maker in this scenario. You finally have the gas station data and you begin informing your colleagues the data is available within the app. Within minutes, 50 people have viewed the data and used it to inform response efforts. So this sounds like a win, right? So the previous scenario happens a lot and could potentially have major implications for disaster response situations. Had decision makers referenced the gas buddy data a week later, they would have been using old data, which could have, at best, delayed response. At worst, it could have resulted in a safety incident. So the operational readiness levels model was created to mitigate this. The ORL model is a tool that allows us to translate the operational readiness of a data set from technical data characteristics to an easy-to-understand standardized ranking. Data sets are ranked between 1, which is the highest level of operational reliability, as Tom mentioned, to a 4, which is the lowest level of operational reliability. The GIS analyst can quickly rank the data set using preset criteria. When they pass that data along to a decision maker, that person immediately understands the reliability of the data set without having to sort through the technical details. As the data set gets passed along to other decision makers, the ranking travels along with it. The power of the model is in the immediate recognition of data set reliability and of its shortcomings, which allows for decision makers to make better data-driven decisions and ultimately for data providers to provide better data. So if you look here, we've included an image, and I think Tom had this in one of his slides. This is just a high-level overview of the ORL model and the different rankings. So we would say that data that's ranked at an ORL level of 1 or 2 is fully operational. So users of these data sets can make decisions with high levels of confidence. The data sets that are ranked at a 3 or a 4 are considered non-operational, but people can still use these data sets. They just should exercise caution in the way the data is interpreted. So it's more about having a level of awareness of the level of confidence of the data going into making decisions with the data. So I'm going to show you all, well, first we're going to talk about why ORL. So for GIS professionals, the operational readiness levels model allows for a built-in questioning attitude when discovering new data sets. So if you're tasked with finding data and you come across something, a lot of times the common response is to just grab that data and run with it, which is understandable given, especially if you're in a disaster response situation, you're under a lot of pressure, but that can be very dangerous. And like with the gas buddy data example, that rep service was not being updated. It was a static data set that was uploaded to the internet, and then it was left there. Nobody was actually updating the data. But nothing in the actual data in the rep service or anywhere else indicated that. So those kinds of situations can be very impactful on response and recovery. So it's important that GIS analysts have that questioning attitude when they are discovering data. It also allows for the standardization of processes and the communication of reliability. So a lot of times, when we're working with people in operations and we're sending them information, we're not going to sit down and explain each aspect of the data, how often it's updated, is it going to go down, what's the resolution of the data. We can do that, but then that information won't necessarily travel with the data. Once we send it out, it's out there and people are using it. So the ORLs allow us to kind of package all of that technical information into a standardized ranking, which makes that communication much more efficient. And it also reduces liability. So this is an important thing to mention, but if you're a GIS analyst or you work in GIS and you provide data that is bad data and something happens, that is going to ultimately come back on you, and there are going to be a lot of questions asked. So this just allows GIS professionals to put up kind of a protective shield, so to speak. If there is something that happens, we can always fall back on, well, we did verify this data, and the ORL level exemplifies that. For those in operations and those who are decision makers, the ORL model provides a simplified and rapid understanding of data reliability. You don't have to come through those technical characteristics. You immediately know right away how reliable a data set is. It also improves safety and efficiency as a result of reducing that level of risk. And it ultimately allows decision makers to make more informed decisions. You know, they have an awareness of the level of confidence of the data going into making a decision, and they also know if they need to exercise a little bit more caution. So now we're going to actually take a look at the model itself. So to demonstrate that, what we've created is a decision tree. So the decision tree allows the user to start at a certain step and basically ask questions about the data, working your way down until you reach an ORL ranking. So I'm going to zoom in here a little bit. So the first question that you would ask always is this data from a trusted and vetted source? So if the answer is no, we actually recommend that you not rank that data set on the ORL model. The only reason for that is if you don't know the data source and it's not trusted and vetted, you shouldn't use that data set at all, period. Just because of the example I mentioned with the gas buddy data, we had no idea where that data came from, and so using that is incredibly risky. So in order to rank data on the ORL model, you have to know the data source, and it has to be a trusted source. But if the data set does come from a trusted and vetted source, you keep moving down these questions. The next question deals with security. Is it SSL encrypted, and does it use HTTPS? If yes, you move down. If no, it actually brings you down to an ORL ranking of 3. Then you ask how interoperable is the data. So interoperability refers to how easily shareable and consumable the data set is. So the most interoperable format we would say is probably a REST service, and going beyond that, probably a feature service. Obviously, some map services do not, allow access to the feature service, which would negate the ability to do analytics. But a feature service would be the most interoperable data format. Mostly interoperable would be something like a shapefile or a geodatabase, formats that are still easy to consume within a GIS framework, but aren't maybe as quick as a REST service. But if the answer is no, it's not interoperable at all. So let's say you get sent a PDF, right, that has a screenshot of data points on it. That is not interoperable. That is not consumable within a GIS, and we would say that would not be ranked on the ORL model. The next criteria deals with service availability. So this has to do with whether or not the service experiences downtime. So downtime can be scheduled downtime, or it can be, during an event when everybody wants to see that data. Is it going to go down? So downtime also influences the ORL ranking. Change notification refers to whether or not there's some mechanism for informing the user if there's something that's changed with the data. So I'll give an example of something that happened a couple years ago. I accessed it was a radar, base reflectivity radar service. I believe it was from NOAA. And we had consumed it in a web map, and a few months later, they actually changed the symbology of the service completely. It didn't even look like the same data, but there was no real method for notifying users that this change was coming. So something that could work for this would be, a web interface. I know that NOAA often has websites where you can access their GIS data and then they give information about it. An email sort of list or something along those lines that will notify users of changes. The verified and tested step has to do with whether or not the data is in a testing or development phase. So oftentimes, organizations like NOAA will put out data that is in development. It's not been completely proven through. It's still being tested. Those data sets can be extremely useful, and they should be used just with caution. So if the data set is in a development phase, we rank that at an ORL 4. And then metadata completeness, I have more in-depth information about this on the next slide, but that has to do with information on the back end about the data. And, metadata is really important. It can often be something that is skipped over. So how complete the metadata is will impact the ranking as well. So that is an overview of how the model actually works. And I will mention that we are working on a Survey 123 form that will actually allow a user to consume a data set and then answer these questions in a really easy form. It's very quick. So we really want to keep it simple and keep it quick. I think that's a lot of the power of the ORL models and its simplicity. So this slide just goes into more detail on each of the criteria that I discussed. So, for example, here we go into, this is the interoperability question, and it actually tells you guidelines for how to answer yes, how to answer mostly interoperable, and how to answer no. So it gives guidelines for that. Also, metadata completeness. So we actually list out each component of information that we want to see in the metadata. So that includes latency or temporal resolution, spatial resolution, guidance for interpretation, and that one's really important. A lot of times you'll see data sets that, they're really useful, but they don't include information on how to interpret the data, which is very important. The source of the data and contact information. So contact information is something that you don't see very often, but a lot of times, especially if the data is coming from NOAA, there will be an email address that's listed on the actual REST service endpoint page. So I've actually emailed them before. I think it's IDP GIF, and they've answered questions for me. So that's very useful. So if it's missing some components, you would answer some missing components, and if it's missing all of the components, the answer would be no, the metadata is not complete. We also have a couple of notes about service availability. This one's a little tricky because you're not always going to know what the availability of a service is, but a lot of times you can ask, if it does have that contact information, you can email them and ask, what's the availability of the data service-wise. So usually they can answer that question, but to answer yes, the service must be available at least 95% of the time. So you can also confirm this by using a service like AlertSite, which allows you to monitor API performance. Excuse me. So I've actually used AlertSite in the past with our external APIs just to see, if they're lagging or if they're going down during an event, because that can actually hinder the performance of your web app. So that is just some detail on each of the criteria. So Tom mentioned dashboards a couple of times. We are working on dashboards that will bring in ORL 1 data. So there's some new tools from ESRI as well that are really great for showing information as well as data. So we're going to be leveraging those new technologies as they come. But this dashboard just shows an ORL 1 data set and a description of what the data sets are. So these are just some examples. Many of you have probably seen the National Weather Service watches, warnings, and advisories layer that we ranked at an ORL 1. The Now Coast Tropical Cyclone tracks, watches, and warnings, that one is a 1. So that's just an example of some ORL 1 data sets. And that is all I have.
That's great, Carrie. Thank you so much. Let's open the floor here for some questions. They prime the pump just with a question that I'm sure might be coming to some of us, and it's something you've discussed internally within Duke many times, I'm sure. As you work with your own utility and bringing information that you have to offer into this space, how does the consideration of NERC constraints fit into the process?
So you're referring, Randy, to internal data, right?
Right. Critical information or critical infrastructure information constraints for bulk electric system data
Right.
is something that we have to be sensitive to. Does that come up in discussions, or is that really not a part of the work you've been doing here yet?
So I would say that it hasn't really been a part of the work we've been doing, and here's why. The ORL model is really most effective for outside data. And by outside data, I mean outside of your organization. So in this case, at Duke Energy, we wouldn't really rank internal data sets using the ORL model just because it's internal. First of all, we can't share it outside of Duke. But then also the considerations for the reliability are totally different for internal data than external data. There's all these other considerations that go into it. So I would say this is more for external data that's put out by government organizations, or data that's shared, not data that is critical.
Yeah, Randy, this is Tom. Can you hear me?
Yes.
A good example of this is the federal government through DHS, runs their NOC, right, where they have their cyber and physical security information. Duke's data, since they own it, is automatically an ORL1. But much of the data DHS has is not their own. They get it from various sources, and they have a keen interest in ranking this because when they share out information with states or private sector, one of the big things they are faced with is, we haven't really ranked our data. We don't know if it's refreshed this week or last year sometimes. I'm being facetious, but you got the idea. So what the ORL helps everyone do is build composites. Your data layered with anyone else's, right? This morning we saw data, aerial data. You were on the call. And by itself, the data was okay. But when you match that with electric utility infrastructure within a given zip code or a given area, it becomes much more powerful. If on top of that, you lay the routes, the comms towers, and the fuel supply lines, that becomes a product very unique. Well, to do that, you got to know all those data layers are ranked in our world. Then you can make a decision. Otherwise, you're going to spend a lot of time, as we've learned in the past, validating, well, who's got that data? Where did you get it? How do we rely on it? And they spend a lot of time, they spend so much time fact checking that it might cost them an hour or two, and that could be a big deal. So there's a practical application of how this works. But if you own your own data, you don't need this necessarily. If you share it, that's where the standard comes in.
I'm curious, Carrie, is there a dashboard you can pull up right now and move into some of the fires in California to show what information might be accessible or being accessed at the moment by responders?
Tom, I'm going to defer that question to you. Do we have a dashboard that shows that?
Hang on one second. I think we do. Let me double check.
One of the reasons I'm asking is that we do have a lot of focus right now going on internally within EPRI around wildfire management and pulling together multiple information sources, not just about the fire itself, but about water, other environmental aspects of events like that. And I was just curious if there was something online right now that would be vetted, if you will, through the ORL framework.
Yeah, hang on one second here. We are, if you share the screen with me, Randy, or how do I do this here?
Yeah.
Well, hang on. If you just go to the following web address, everybody can look at it. It's FRWG, Fleet Response Work Group, FRWG.geocollaborate.com. I have the screen. I think you gave me the screen as well. Let me double check. How do I share my screen here?
If you scroll over there you go.
There we go. It's been a while. Thank you. So this is a dashboard developed by Storm Center Communications. It was a $5 million NASA investment that does what very few GIS tools does. It actually merges them into a common operating picture as one integrated data layer. It's not layering data, it provides it all in. The second thing it does, it allows it to share data without you taking possession of my data. And that gets us around FOIA issues for government and state. But if you look here, if I can zoom in here, this is, if I can find the wildfire layer, I think it's on already. So if I click on this, this gives us the, Carrie, I guess this is the part of the metadata that we're getting from the provider, which I think is NIFC. Okay. So if I zoom in, you'll get a chance to see it. And this is the type of capability, Randy, where we want to make sure see these data layers over here on the left, ORL1, ORL2. This is kind of what we need as we get to this, that they won't even be in a dashboard unless they're a 1, right? And we're still working through that process, but this will give us wildfire data, infrastructure data, comms, fuel, retail. The idea is to pull all that together in a secure environment where no one has possession of it, but they can see it and use it. Fantastic capability. Thank you, NASA and Storm Center. And then our goal is to continue to aggregate data sets, and build use cases or problem sets, if you will, around some of these. But anyway, I hope that gives you, I'll see if I can find the other two. There's 2 other layers here that I wanted to show you here, but it gives you an idea of what we're in, if that answers your question.
Yeah, thank you. Any questions from those who are on the call? For Tom or Carrie? Okay.
Yeah, I think through the webinar it's not loading as fast, but we get data. We get data from a variety of sources through our partners at NASA and NOAA, and we have this pop-up window that gives us, real-time indication, whoever's providing that lead, right? So, and then we can refresh it, and then we get indications like, here's a good example. So this gives us the information that we need. So we use this for a number of different use cases, but at the end of the day, this gives us the idea of a specific incident, or as you can see over here, we had the windstorms come through this region here on the East Coast, and we've got all kinds of damage reports that we get live from the states. So why is that important? Well, if you own infrastructure and you got a lot of stuff falling out of the air, you're kind of concerned about it. So, but the idea is not just the data. There's tons of data. As a matter of fact, the private sector tells us there's too much data. What data is reliable? I think I've said that right, Carrie. And once you find the reliable data, then how do you package it in a tool that I can use without training to make a decision in 30 seconds? That's what the SISE work group does. It's a fantastic, creative group. I mean, Carrie and I laugh all the time. They created 9 products in 8 months. From my experience, making one product took 18 months, right? So this group is very innovative, and we welcome any of you folks that want to become part of that to join in. So.
This is Charlie Schaefer from Ameren. I do have a couple questions.
Yeah, go right ahead. Sure.
So, I'm wondering if we have a use case, how do we get started? How do we? I mean, do we do it ourselves? Do we? You know, it looks like great stuff to collaborate across organizations, but I'm wondering how we would use it in order to do something useful for our constituents.
Yeah, this
How
is.
do we engage? How do we put something?
So, Carrie, I'll take a shot at that. I'm sorry, first name again?
Charlie.
Charlie, okay. Charlie, if you give me an example of what you're thinking about, if you can, real quick, I can better answer the question. If
Well, yeah, the first thing is obviously mutual assistance with hit by a major storm. We want to coordinate a lot of stuff with everybody, contractors, other utilities that are coming in to help us. So we'd want to make some information available. We want to get some information from them. How would we make that use case work?
Very good. Well, there may be something already in the oven you could tap into. We should talk because we've created, most of the products we've created have been around mutual assistance in the very beginning, right? So there may be a product already there that you could leverage without forming a committee, right? The second part is we talk, and in some cases, like in the fuel sector, they had a use case where their fuel drivers could go to 4 different sites ranging from an hour away to 4 hours away, but they had no idea of the long lines condition at each of those sites. Sometimes it's faster to drive 4 hours away and get the fuel right then than drive an hour away but sit in a line for 8 hours. You know what I mean? So that's a use case we didn't have working. So we work with their trade association, we put together the committee, we resource it certainly, and then we develop whatever, once we understand the problem and the impacts, then we look into current solutions or things that are out there already. It doesn't take long, but mutual assistance, if we've got a number of products already, you might just be able to leverage based on that.
So just leveraging on, let's say we do have a problem to solve. Do we, is there a cost to this? How do we engage? How do we discuss how it might be solved through this?
Yeah, it depends on the nature of the use case. There's a subscriber model available, okay? If you're an EEI member, okay, there's other ways to leverage their resource because they participate in this as well. So we'd have to talk a little more in depth, but yeah, I think the cost you'll find is nominal. And like I say, many times, especially mutual assistance, we've done use cases for expediting across the border in Canada into the U.S., which is a big issue. We coordinate with multiple states. We expedite waivers and declarations. We get into way stations. As far as mapping those, we're working with DOT to help determine can they close them along the way, which we did during Maria. So I'd have to talk further. It's kind of hard on a webinar, but we'd have to talk further. And if you want to send me an email, I'd be glad to chat with you further about it. But there may be some things already in place. I always look to what we have already. If we can fit that, versus going through another effort might save time.
Is that something that you can publish what you have already, or is that on the site we can look through? Maybe you've already solved our problem.
Let's see. I'd have to send it to you. It's not publicly out there. And again, if I understand the specific nature of your use case, then I can provide it for you. Okay. You might have something unique. I don't know, but I assume when you're talking mutual assistance, you're bringing other utilities and contractors, moving them somewhere across state lines for assistance, like what's going on in New England right now, right?
Yeah, it's like hurricane response, but not as bad and big as a hurricane.
Yeah, got it. Do you have my email?
Who's speaking? Is that Tom?
This is Tom. Yeah. It's
I don't think I have that.
It's
Rattle it off.
yeah, it's tom.moran@ahcusa.org. Okay? Be glad
All
to.
right. Thank you for that question, Charlie. We have just a few minutes left. Let me just walk through some recent activity and mention a couple of upcoming events that I think will be of interest to you all. We had a launch at our Nashville Advisors Conference of a new project set called 161H, Geospatial Informatics. This is a program or a set of projects focused at utility GIS professionals that will continue about 7 years of research on a project basis in the past, consolidate that into basically 3 buckets in 2020. The first is data practices, where we'll develop some guidebooks on geodata management. We'll focus on how geospatial will support augmented reality, virtual reality, and other applications that are really coming quickly beyond the mobile apps that we know today. And then in the analytics and visualization space, we have a co-funded project with another program that focuses on modeling for advanced grid analytics, both for operations and planning. This interest group will continue with a bit more emphasis and funding. We'll have 2 face-to-face meetings in 2020, and we'll bring more information on that in the future. We are currently, right now, working on a roadmap. This will be published in just a few weeks, where we look ahead 5 years, specifically for this project set. So in these 3 buckets, I've sort of listed here what I've heard from currently funded projects and from those who are involved with that in the GIS space. Just to give you sort of a look ahead on what we hope to help you with as GIS professionals down the road. And we certainly are at a point right now where we could really use your feedback on this gap analysis. What do we need to accomplish in 2020, 2021, and maybe even 2022 to get us there? And I've just listed here some verbatim comments that I've received. We've had 3 calls in the last couple of weeks with 5 utilities, and then I have another call coming this afternoon to kind of walk through the roadmap in some detail and to kind of harvest your perspective in these 3 areas. So do reach out to me if you'd like to be involved in that conversation. Next up, we have a Digital Worker Symposium. This is coming up just 3 weeks from now, I think, November 19th. And I snapped in just a copy of the current agenda for that. It's just a day and a half. It takes place in Charlotte on the EPRI campus. And we would certainly enjoy anyone from the organizations that would like to come in and join in this discussion. Richard from First Energy has been part of some of our GIS projects here. He'll be joining me to talk about how geolocation services are going to be needed for future XR applications. A lot of stuff around AR, VR, and all the projects that have been going on in that space at this conference. And then next spring, we have 2 conferences, or next year, we have 2 conferences coming up. We have 2 advisors conferences per year, one in the spring, one in the fall. So next up is Dallas, February 10th to the 12th. And we will be bringing together a lot of the folks that have been involved with GIS, those who've been on this interest group, and who are voting in to get this geospatial informatics program launched in 2020. And then plan Florida for the September timeframe. If you'd like to reach out to anyone, these are contacts within EPRI who are quite familiar with everything I've just mentioned. Technical assistants are those who help you to purchase programs or to engage with EPRI. We have one for the east, the west of the Mississippi, and Canada. And internally, you have a MEP, which is the individual who is the direct liaison with EPRI. And then you have specific advisors within certain departments, distribution operations, planning, and so forth. And that's another way to get in touch with us. And with that, I'd like to wrap up our talk today by thanking our speakers. Thank you, Tom. Thank you, Carrie. Great input and very thought-provoking. This is an area that we haven't delved into very much yet as an interest group, so appreciate you guys breaking the ice for us. We will send out a PDF copy of this to attendees and to the entire GIS interest group that have been attending these in the past. With that, thank you for attending, and you all have a great day and a great weekend. Linda, I'll let you close the call. Thank you so much.
All right. Well, thank you, everyone, for attending our webcast today. And if you don't have any further questions for Randy or our speakers, Tom and Carrie, we will conclude the meeting, and you have a great rest of your day.
Thank you.
Thank you.